Hello students, alternating current we were discussing multiple choice questions. So we are going to continue with the same lesson with few more questions. Okay, see the next question for today's class. Okay, see. A coil having zero resistance is connected in series with a 90 ampere resistance and the combination is connected to 120 volt 60 hertz line. A voltmeter reads 36 volt across the resistance and 114 volt across the coil. The self-inductance of the coil is. So here they are asking the self-inductance of the coil. So let us see how to calculate the self-inductance of the coil. To calculate the self-inductance of the coil, they are giving you, it is having zero resistance anta helidare. Current is given as 90 ampere. And the next, it is connected to 120 volt and 60 hertz line. So frequency is given here. Yes. And the potential is also given. Voltmeter reading is given. So let us calculate the self-inductance in the coil. So here, that is BL is equal to I into XL, which is equal to I into 2 pi F into L. So therefore, we require the self-inductance L value. Therefore, L is equal to, it is VL divided by I into 2 pi F. Correct? So I value, here we can also take it as VL value, let us substitute 114 divided by I value, I'll take it as V by R, that is 36 divided by, it is 90 into 2 pi into frequency is 60. Okay. So here the options what they are giving is, option A is 0 0.076, 0 0.76, 7.6, 76 Henry. Okay. So here if you simplify 114 divided by 36.90 into 2 pi into 60. So here 0 0 will get cancelled. 3 2s are 3 3s are. Then 3 1s are 3 12s are. 12 into 2, 24 pi. So 117 divided by 24 pi. That is nothing but, here if you simplify this one, you are getting it as 0 0.76 Henry. So 0 0.76 Henry is the answer. So option B is the correct option here. 0 0.76 Henry. Option B is the correct answer. Okay. Go for the next question. The choke coil has a resistance 8 ohm and the inductive reactance is 6 ohm. The power factor of the coil is, so here the power factor of the coil is asking. Therefore, cos pi is equal to n martira. So power factor cos pi is equal to, it is R divided by Z. So it is R divided by Z, which is equal to R, keep it as it is, divided by Z. So Z is nothing but what? R square plus XL square. So this is equal to R value. It is 8 divided by under root of R square plus XL square. So R square is 8 square plus XL value is 6 square. Inductive reactance under the root. Okay. So it is 8 divided by under root of 8 square plus 6 square. Therefore, cos pi is equal to, the answer is 0.8. So option B is the correct answer. So just you need to calculate the power factor here. So power factor cos pi is equal to, you are going to take it as what? that is R divided by Z. Okay, so let us go for the next question. Okay, see the next question. A radio tuner has a frequency range from 500 kilohertz to 5 megahertz. If its LC circuit has a effective inductance of 400 picohenry, the range of its variable capacitor is. So the range of the variable capacitor, capacitance value they are asking, take pi square is equal to 10 anta ಹೇಳ್ತಾ ಇದ್ದಾರೆ. So see how to calculate the capacitance range. Okay, so here it is given by F minimum is equal to how much they are saying. F minimum is equal to, it is 500 kilohertz. Then next F maximum is equal to how much it is. F maximum is equal to, it is 5 megahertz. 500 kilohertz and 5 megahertz. Okay, so the corresponding to F minimum we have, that is F minimum is equal to, it is 1 upon 2 pi under root of LC maximum, because illenagatte andre frequency minimum adaga il capacitance alli maximum agutte, because they are inversely proportional to each other. Therefore C max is equal to, so C max is equal to, it is 1 divided by square root alli irodrinda navu full equation anna square madbekagutte. It is 4 pi square F minimum square into L. So which is equal to 1 divided by 4 pi square value 10 ತಗೊಳ್ಳಿ ಅಂತ ಹೇಳಿದ್ದಾರೆ. So directly I can take it as 10 into Fm square. So Fm value is, the minimum value of frequency is given as 500 kilohertz. It is therefore 500 into 10 raised to 3. Okay. The next L value. So L value is given as what? 400 pico Henry. It is actually micro. Okay, it should be micro, then we will get the option, otherwise option will not be there. So here it is 500 into 10 raised to 3, and here it is 400 into 10 raised to minus 6. So here if you simplify this one, 1 divided by 4 into 10 into 500 into 10 raised to 3 into 400 into 10 raised to minus 6. So this is equal to, it is 2.5 into 10 raised to minus 10 farad, 2.5 into 10 raised to minus 10 farad, or you can also write it as what, 250 into 10 raised to minus 12 farad, or you can also say it like 250 picofarad anta kuda helabodu, 250 picofarad. Okay, so options here you can see 250 picofarad is there for only one option, so therefore directly we can choose option A. Will by chance or ಮತ್ತೆ ಯಾವ್ದಾದ್ರು option same ಕೊಟ್ಟಿದ್ರು ಅಂದ್ರೆ, then same way we have to calculate the C minimum also. So ನಾವಿಲ್ಲಿ ಏನ್ ಮಾಡಿದ್ವಿ, C maximum ಅನ್ನು find out ಮಾಡಿದೀವಿ, so C minimum ಕೂಡ find out ಮಾಡ್ಬೇಕಾಗತ್ತೆ. So same formula, only the difference is what, you have to take the value of f square 5 megahertz ಅಂತ ತಗೊಳ್ಬೇಕಾಗುತ್ತೆ, 5 megahertz. So ಈ first simplification ಅಲ್ಲಿ 500 ತಗೊಂಡಿದ್ವಿ, second simplification ಅಲ್ಲಿ 5 megahertz ಅಂತ ತಗೊಳ್ಬೇಕಾಗುತ್ತೆ. Okay, so therefore if you simplify there, you are going to get it as 2.5 picofarad. Yes, so here option A is the correct answer. Go for the next question. In a series LCR circuit, electrical energy is not consumed in, so electrical energy is not consumed in option A inductance, option B capacitance, option C resistance, and option D both inductance and capacitance. So it is option D, both inductance and capacitance. So in the LCR circuit, electrical energy is not consumed in both inductance and capacitance. Option D is the correct answer. Okay, hope so. Next question is the same only. So let us go for the next question. Okay, so here is our next question. In a series LCR circuit, the voltage across the resistance, capacitance, and the inductance is 10 volt each. If the capacitance is short circuited with, voltage across the inductance will be. So in a series LCR circuit, the voltage across the resistance, capacitance, and inductance is 10 volt. If the capacitance is short circuited, the voltage across the inductance will be. So options 10 volt, 10 root 2 anta ide, 10 volt anta ide, 20 volt anta ide. So see how to calculate the value of potential drop. So here it is. Z is equal to, so we are going to calculate Z is equal to, it is under root of R square plus XL square. But if you see the value here, the voltage across the resistance, capacitance, and the inductance is 10 volt each anta ಹೇಳ್ತಾ ಇದ್ದಾರೆ. Therefore, when the capacitor is short circuited, here we can substitute this XL is equal to what? That is R anta substitute ಮಾಡ್ಕೋಬಹುದಾಗಿದೆ. Therefore, this is nothing but R square plus R square. That is nothing but 2R square. So therefore, it becomes 2 root of R. It is nothing but 2 root of, sorry, R root of 2. So here R will come out, that is R root of 2. Now, here the new current is given by I dash is equal to V divided by Z. So that is nothing but V value 10 volt anta helidare. Z value is R root of 2. It is R root of 2. So this is the value of I dash. Now the potential drop is calculated as. So the potential drop or the PD across the inductance is. So across the inductance is given by I dash into XL, which is equal to I dash into R anta helbodu because the capacitor is short circuited. So I dash value is 10 divided by R root 2 into R is there. So R will get cancelled. Therefore, we are going to get it as what? 10 root 2. Sorry, 10 divided by root 2. So 10 divided by root 2. Actually, options only. Option A is 10 volt. Option B is 10 into root 2. Option C is 10 volt. 10 divided by root 2 anta ide. And option D is 20 anta kottidare. So therefore, option C is the correct answer here. So copy down what we have done here. As it is short circuited, the value of XL is equal to R anta agate. Therefore, just take XL is equal to R, simplify, Z is equal to R root 2 anta bantu. Then after that, what you are going to do? I dash is equal to. V by Z. So V is 10, Z is R root 2. Therefore, potential difference across the inductance is given by what? I dash into XL. So I dash into R, that is I dash value into R will get cancelled. Therefore, you will get 10 divided by root 2. Okay. So go for the next question. So see the next question. In a LCR circuit, resistance R is equal to 10 ohm and the impedance Z is equal to 10 ohm. So ಇದು ohm ಆಯ್ತಾ ಇದೆಲ್ಲ ohm ಇದೆ. The phase difference between the current and the voltage is. The phase difference between the current and the voltage is. So you have a LCR circuit whose resistance is given as 10 ohm and impedance is given as 10 ohm. The phase difference you need to calculate, that is nothing but tan pi you need to calculate. So tan pi is equal to, heg martira, tan pi is equal to, it is XL minus XC divided by R. Okay, so let us calculate what is XL minus XC. So XL minus XC, how we are going to calculate? That is nothing but Z is equal to under root of R square plus XL minus XC whole square. R square plus XL minus XC whole square. So which is equal to Z is equal to 10. So substitute 10, which is equal to under root of R square. R square is 100 plus XL minus XC whole square. So we require XL minus XC. So what we need to do here, taking square on both the side and the square root cancel agatte. Therefore, this is nothing but 100 is equal to 100 plus XL minus XC whole square. So 100 minus 100. So 100 minus 100 is nothing but what? 0. So therefore your XL minus XC value, what you are getting? XL minus XC is equal to 0. So what I told you, ನಾನು ನಿಮಗೆ ಏನು ಹೇಳಿದೆ ಇಲ್ಲಿ, tan pi is equal to ಹೇಗೆ ಮಾಡ್ತೀರಾ? Tan pi is equal to what? XL divided by XC divided by R. So XL minus XC is 0 divided by R, keep it as it is. So this is nothing but it is equal to 0. So tan pi is equal to 0 anta baratte. Kottiro options alli 0 degree ಇದೆ, 30 degree ಇದೆ, 45 degree ಇದೆ, 60 degree ಇದೆ. So therefore option A is the correct answer here. Option A is the correct answer. Okay. Then the next question is, in an LCR circuit having L is equal to 8 Henry, C is equal to 0.5 microfarad and R is equal to 100 ohm in series, the resonance frequency in radian per second is, in radian per second is. So how to do this one? Okay. Here we need to calculate the resonance frequency. So resonance frequency andre omega anta agate. That is omega is equal to 1 divided by under root of L into C. So therefore, omega is equal to 1 divided by under root of L. L value is 8 into C value. It is 0.5 into 10 raised to minus 6. L into C value. Okay. So therefore, this is equal to 1 divided by 8 into 0.5 into 10 raised to minus 6. So that is nothing but what? 2 into 10 raised to minus 3. 1 divided by 2 into 10 raised to minus 3. So 1 divided by 2 is nothing but what? 500 radian per second. It is 500 radian per second. So that is nothing but option D is the correct option here. Option D is the correct option. Okay. Let us go for the next question. In a LCR series circuit, the potential difference between the terminals of the inductance is 60 volt, between the terminals of the capacitor is 30 volt, and across the resistance is 40 volt, then supply voltage will be equal to, yes, how to do this one? Here, V is equal to under root of VR square plus VL minus VC whole square. So this is equal to VR is 40 square plus VL minus VC. That is nothing but 60 minus 30 whole square. So this is equal to 40 square. 4 square is 16. So that is nothing but 1600 plus 60 minus 30 is 30. 30 square is, so 3 square is 9. That is nothing but 900. So it is 1600 plus 900. Therefore, this is equal to, it is nothing but 2500 under root of 2500, which is equal to, it is 50 volt. So V is equal to, it is 50 volt. Correct. So therefore, option A is the correct answer. So 50, 70, 130, 10 anta kottidare. Therefore, option A, 50 volt is the correct answer. Then the next question. In an oscillating system, a restoring force is must. In an LC circuit, restoring force is. So LC circuit alli restoring force compulsory anta ಹೇಳ್ತಾ ಇದ್ದಾರೆ. So that restoring force is option A, capacitor, inductance, resistance, both A and B. Here A restoring force is because of the inductance. That is option B. Inductance is the correct answer here. Option B, inductance. Okay. Then the next question, if a resonant AC circuit contains a capacitor of capacitance 10 raised to minus 6 farad and an inductor of 10 raised to minus 4 Henry, then the frequency of electrical oscillations will be, here the options they are giving as that is 10 hertz, 10 to the power of 5 hertz, 10 divided by 2 pi hertz and 10 raised to 5 divided by 2 pi hertz. So if a resonant AC circuit contains a capacitor of capacitance 10 raised to minus 6 farad and an inductor of 10 raised to minus 4 Henry, the frequency of the electrical oscillations. Here, the frequency of the oscillations is given by F is equal to under root of 2 pi root of L into C, which is equal to 1 divided by 2 pi under root of L into C. So it is nothing but what? 10 raised to minus 6 into 10 raised to minus 4. So that is nothing but it is 1 divided by 2 pi. 10 raised to minus 6, 10 raised to minus 4 is 10 raised to minus 10. So 10 raised to minus 10, if I take it out, it will be 10 raised to minus 5. So therefore, it will be 10 raised to 5 divided by 2 pi. So 10 raised to 5 divided by 2 pi, that is option D is the correct option here. Option D is the correct option. Okay. Then the next question. An LCR series circuit with 100 ohm resistance is connected to an AC source of 200 volt and an angular frequency of 300 radian per second when only the capacitor is removed. So LCR circuit in the capacitor remove the current lags behind the voltage by 60 degree. When only the inductor is removed, the current leads the voltage by 60 degree. So yavag inductor anna tegitivi avaga current leads the voltage by 60 degree. The current in the LCR circuit is so options what they are giving, options they are giving it as what, that is 2 ampere, 2.5 ampere, then 3 ampere, 1.75 ampere. Yes, how to calculate this? See. So here it is. So when the capacitor is removed, tan pi 1 is equal to, it is XL divided by R, or XL is equal to R into tan pi 1, which is equal to 100 root 3 yes So R value is given as 100 ohm and tan pi. So that is nothing but what? Tan 60 is root 3. So therefore it is 100 root 3. This is first case. Second case, when the inductor is removed. So when the inductor is removed, it is given as, that is tan pi 2 is equal to xc divided by r, or xc is equal to r into tan pi 2. So that is nothing but what? It is r is again 100 and this is again 60. Therefore, it is root 3. This is equation 2. Okay, XC is there, XL is there. Namge em kehta idare, the current in the LCR circuit is. Okay, so here the current in the LCR circuit is given by I is equal to V divided by Z. So here XL, XC, both values are same. Therefore, here the Z is nothing but what? V divided by R anta tagoltivi. Therefore, V value is 200 and the R value is 100. So this two zeros will go and we are getting the current as what? 2 ampere. Current as what? 2 ampere. Option A is the correct answer. Option A is the correct answer. Okay. Go for the next question. If a resonant AC circuit contains a capacitor of capacitance 10 raised to minus 6 farad and an inductor of 10 raised to minus 4 Henry. So this is similar to the first one. So leave it. Go for the next. So here in an oscillating LC circuit, L is equal to 50 millihenry and C is equal to 4 microfarad and the current is initially maximum, time taken by the capacitor to discharge fully for the first time is. So the time taken you need to calculate to discharge fully for the first time. So that is actually frequency and time, they are reciprocal to each other. Therefore, it is given by as T is equal to 2 pi under root of L into C, which is equal to 2 pi under root of L into C value. So L value is 50 milli. So it is 50 into 10 raised to minus 3. Then the capacitor value is 4 into 10 raised to minus 6. So therefore, here if you simplify this, it will be 28 into 10 raised to minus 4 second. Okay. So, but here see, in an oscillating LC circuit, L and C, and the current is initially maximum, the time taken by the capacitor to discharge fully for the first time is. Correct. So here the required time we need to divide it. The required time we need to divide it by 4. Therefore, T divided by 4, which is equal to. So T is how much? 28 into 10 raised to minus 4. Divided by it is 4. So that is nothing but 7 into 10 raised to minus 4 seconds, or 0.7 into 10 raised to minus 3 second, or you can also write it as 0.7 millisecond. That is option C is the correct option here. C is the correct option. Okay. Go for the next question. A transformer has 400 turns in the primary and 800 turns in the secondary coil. The primary is connected to a supply of 220 volt and at a current of 10 ampere. The voltage across the secondary and the current through it respectively are. A transformer has 400 turns. So primary coil ಅಲ್ಲಿ 400 turns ಇದೆ, secondary coil ಅಲ್ಲಿ 800 turns ಇದೆ. The primary is connected to the supply of 220 volt. ಮತ್ತೆ current ಎಷ್ಟಿದೆ 10 ampere ಇದೆ. Then the voltage and the current in the secondary is. Okay, so this is based on the transformer concept. Here, that is for the transformer, Vs divided by Vp is equal to ns divided by np. Therefore, vs is equal to, it is ns divided by np into, it is vp. So this is equal to, it is 800, that is number of turns in the secondary coil, divided by number of turns in the primary coil, into vp value. So vp value is 220. So here 0 will get cancelled. Here also this 0 will get cancelled. 4 ones are 4 twos are 22 into 2, that is 4, that is 440 volt. So this is Vs, that is the voltage in the secondary coil. Let us calculate the current in the secondary coil, that is given by Is divided by Ip is equal to Np divided by Ns. So which implies Is is equal to Np divided by Ns into Ip. So again, number of turns in the primary coil is 400, in the secondary coil is 800, into IP value is, it is 10. So here this 0 will get cancelled. This is 1 za, so one more 0 will go. 10 za, this is 2 za. 10 divided by 2, 2 ones are 2 5s are. So that is nothing but what? 5 ampere. That is 440 volt and 5 ampere. So that is option A is the correct answer here. Okay, so very simple. Copy down, we will go for the next question. So the next question is, a transformer has, so this is completed. Next, in a LCR series circuit, the potential difference between the terminals of the inductance is 60 volt, between the terminals of the capacitor is 30 volt, and that of the resistance is 40 volt, then the supply voltage will be equal to. So this is also, yes. So here this question is also repeated. So already we have solved here. You can see this. Today's first question only it is. Okay. So what we will do, we will continue in the next class with a few more questions on the AC topic. Okay. So thank you, students.